Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0843, refers to a transmission fluid pressure sensor switch A circuit high issue, specifically affecting Honda Civic models from 2016 to 2021. This code indicates a problem related to the electrical circuit of the transmission fluid pressure sensor, but not to a mechanical failure in the transmission itself. The transmission fluid pressure sensor is crucial as it measures the hydraulic pressure within the continuously variable transmission, CVT, helping the transmission control module, TCM, optimize vehicle performance. The sensor is typically located on the CVT assembly, connected through a 3-pin connector. Failure to read accurate pressure can lead to erroneous signals to the TCM, resulting in performance degradation or transmission malfunction. Being aware of this DTC is vital for effective diagnostics and repair to ensure optimal vehicle functionality. DTC P0843 signifies an electrical circuit problem linked with the transmission fluid pressure sensor. This is not a mechanical issue and is exclusively related to electrical connections and signals. The CVT fluid pressure sensor plays a pivotal role by detecting the hydraulic pressure within the transmission, which is crucial for the smooth operation of the vehicle. When the sensor detects high pressure, it sends signals to the transmission control module, TCM, that influence shifting behavior and overall vehicle performance. This sensor is typically situated on the CVT assembly. It is connected with a 3-pin connector, identifiable as the CVT-driven pulley pressure sensor 3P connector. Any faults in this circuit can result in a range of performance issues, making it crucial to address this code promptly. The potential causes for DTC P0843 include a faulty CVT-driven pulley pressure sensor, which may be delivering inaccurate signals due to internal failure. Another cause could be an open circuit wiring issue, where a break or fault in the wire prevents proper signal transmission between the sensor and the transmission control module, TCM. Poor connections can also be a culprit, as loose or corroded terminals between the sensor and TCM can disrupt communication. Such electrical issues need to be diagnosed accurately to ensure proper signaling from the sensor to the TCM. Each cause must be evaluated carefully to isolate the problem and restore functionality to the CVT system effectively. Symptoms associated with DTC P0843 may include erratic or harsh shifting behavior, indicating the TCM is receiving incorrect readings from the fluid pressure sensor. Drivers may also notice warning lights illuminating on the dashboard, indicating the need for a vehicle check. Furthermore, there can be a decline in acceleration performance, resulting from improper transmission fluid regulation. If these symptoms are present, they are indicative of potential issues with the CVT system, and immediate diagnostics should be performed. Addressing these symptoms quickly can help prevent further damage to the transmission system and ensure a smoother driving experience. The first troubleshooting step involves verifying the problem by turning the vehicle to the on mode and clearing the DTC using the Honda Diagnostic System, HDS. After clearing, you will need to check the parameters related to the CVT fluid pressure sensor. This includes reviewing the driven pulley pressure sensor signal to ensure it is reading as expected, which should be more than 4.84 volts according to the diagnostic parameters. The readings you get will help in confirming whether the issue is ongoing. If the current conditions match the threshold, it indicates a duplicated failure, and you will proceed to step 2. If the conditions are intermittent and do not match the threshold, it suggests that the system might be okay at the moment. However, poor connections should be investigated before further diagnostics. In the second troubleshooting step, you'll begin by turning the vehicle to the off or lock mode before disconnecting the CVT-driven pulley pressure sensor's 3P connector. Following this, you will connect terminals A and B using a jumper wire. Terminal A corresponds to connector number 1, while terminal B corresponds to connector number 2. Once the jumper is in place, turn the vehicle back to the on mode, and again, check the driven pulley pressure sensor. Readings with the HDS. The expected voltage should be greater than 4.84 volts. If the current conditions match this threshold, it confirms you should proceed to step 3. But if not, you will go to troubleshooting step 4 to check for deeper issues. In the third troubleshooting step, turn the vehicle to the off or lock mode and remove the jumper wire you connected previously. Next, disconnect the TCM 50P connector to proceed with continuity testing between specific test points. You will check for continuity between test points, CVT-driven pulley pressure sensor connector number 2 and TCM connector number 31, ensuring the vehicle remains in off mode and both connectors are indeed disconnected. This test will help determine if the PDN wire is intact. If continuity exists, it indicates the wiring is in good condition, and you'll need to look into any authorized service information or consider substituting a known good TCM. If there's no continuity, it's necessary to repair any breaks in the PDN wire to restore proper signal flow. Step 4 involves checking the CVT-driven pulley pressure sensor. Begin by turning the vehicle to the off mode and removing the previously connected jumper wire. Then, turn the vehicle to the on mode to get the readings for further testing. You need to measure the voltage between test points corresponding to the CVT-driven pulley pressure sensors number 1 and number 3 terminals. The expected reading here should be approximately 5 volts. If the reading is around this threshold, it confirms that the sensor is faulty and a replacement of the CVT-driven pulley pressure sensor is required. However, if the reading is not as expected, it implies the sensor is functioning, and further testing will be necessary to isolate the problem. The final step involves another voltage measurement under specific testing conditions. With the vehicle in the on mode and the CVT-driven pulley pressure sensor connector still disconnected, you'll check the voltage between the terminals of connector number 3 and body ground. Here, you'd expect to see a voltage of about 5 volts. If this condition is met, you'll need to proceed with repairing an open circuit found in the SG4 wire, which connects the sensor and the TCM. If you do not read about 5 volts, this suggests that the issue lies in the VCC4 wire connecting the sensor to the TCM. In that case, repair the open in the VCC4 wire to restore proper signal flow before confirming repairs and re-evaluating the system. After performing the necessary repairs based on the steps outlined, the next phase is the final repair verification. First, ensure to recheck the DTC codes using the Honda Diagnostics System, HDS. This step is crucial to confirm that DTC P0843 has been cleared and does not reappear. Following that, it's important to confirm the proper operation of the CVT-driven pulley pressure sensor by checking if the readings are within the expected parameters during a vehicle initialization test. Finally, conducting a test drive is vital to ensure that the transmission operates smoothly without erratic shifting or warning lights. Successful validation of both the DTC status and vehicle performance will confirm that the repairs have rectified the issue efficiently. While the primary focus is on correcting the DTC P0843 issue, it's also essential to consider preventive maintenance to avert future problems. Regularly checking transmission fluid levels ensures that the system operates efficiently, as low fluid can affect pressure readings and lead to sensor failure. Additionally, Routinely inspecting electrical wiring and connectors can help identify any signs of wear, corrosion, or damage before they escalate into bigger issues. Keeping an eye on the health of the CVT-driven pulley pressure sensor itself is crucial. Sensors can wear out over time due to environmental factors. By proactively maintaining these components, the longevity and functionality of the transmission system can be preserved, reducing the likelihood of encountering similar DTC codes in the future. In conclusion, DTC P0843 highlights potential complexities primarily rooted in the electrical components rather than mechanical failures of the Honda Civic's CVT system. Understanding the roles of each component involved and how they interact allows for a more effective diagnostic approach. Regular scanning and visual inspections of the related electrical connections are critical in maintaining system health. With commitment to both diligent troubleshooting and preventive practices, you can ensure that your Honda Civic remains in optimal operating condition, thus enhancing vehicle reliability and operational efficiency. The outlined steps serve as a comprehensive guide to resolving this DTC, ensuring you protect your investment and enjoy a smoother driving experience. Please like and subscribe to the channel. See you next time.